Hello students. So in the last class we studied about refraction, its phenomena, how does it occur, what is a medium. So today we are taking up prism. What is prism? How does refraction take place in a prism? What are the factors which affect it? All this we are going to study here. So we begin with prism from the next slide. Now, as you can see in this figure, a prism is a solid made up of glass and it has 3 rectangular surfaces and 2 triangular surfaces. As it is labeled also there, the refracting edge, the refracting surfaces all are rectangular, and you can see the front and the back side is triangular. And therefore, a prism is a solid which is made up of 3 rectangular surfaces and 2 triangular surfaces. Okay, so we move to the next slide. Now, in this figure, you can see that a light ray is entering from the rectangular surface of the prism from one side. So the blue light is the one particular light ray which is entering the prism and is emerging out of the prism. Now you can see PQ is a light ray which is entering the prism. So it is obviously the medium is changing. So from air to glass. So the light ray is moving from air to glass. So at the point at which it strikes the glass medium, a normal has been made. Now you can see PQ and normal make an angle which is known as angle of incidence, or all of you know now. Now it is entering the prism and therefore it is moving towards the normal. You know that if a light ray is moving from a rarer to a denser medium, the light ray will move towards the normal, and therefore the light ray is moving towards the normal. If no deviation would have taken place, PQ would have gone straight to the dotted line towards H as shown in the figure. Now, as refraction has occurred and the light ray has come towards the normal, bending towards the normal, and therefore it goes and strikes the other surface of the prism, which is AC. Now from AC it has to emerge out, and now as a light ray is passing from denser to rarer medium, it is moving away from the normal. So you can see the normal has been drawn over there, M dash, and it is moving away from the normal and it is emerging out as RS. So the labeling has been done over there. Now the light ray which was incident, when traced back, it was going till H, and the emergent ray when traced back with the dotted line, it goes till G. Now the angle which is made between the incident ray and emergent ray when traced back is known as angle of deviation, which is denoted by capital D over here. You can see at point G, when the incident ray and emergent ray are traced back, they are making an angle of deviation over there, and this is angle of deviation of a prism. Angle A is known as angle of prism. In most of the cases it is 60 degree, but we have prisms of angle of prism as 90 degree, 45 degree and others also. But in most of the cases, angle of prism is 60 degree. So this is all about how refraction takes place in a prism. So we move further. Now students, here we are about to prove that angle of incidence plus angle of emergence. That means when angle of incidence and angle of emergence are added together, that is equal to angle of prism plus angle of deviation. So we are going to prove this. It will be taken up in various questions, in various numericals by you people. So I am about to prove the following. Now, if you can see the figure clearly, there are two triangles framed inside the prism. One triangle is MPQ and another triangle is NPQ. There are two triangles formed. Now, as I1 is angle of incidence, R1 is angle of refraction. And here angle of emergence is I2, and for that R2 is angle of refraction. If the light ray would have come from that side and this would have been angle of incidence, then angle of refraction would have been R2. Okay. So I1 and I2 are angle of incidence and angle of emergence. R1 and R2 are the respective angle of refraction from that point. Now, delta 1, that is the deviation from that angle of incidence I1. So, delta 1 is that in the deviation and delta 2 is the second deviation. When these both rays are traced back, the main angle of deviation which is formed is delta. So, there are two triangles formed within the prism. Now, you know the formula for a triangle, you know this identity that external angle is equal to sum of two opposite interior angles for a triangle. You must have studied about this identity that the sum of two interior triangles is equal to the exterior angle. Okay, so that has been applied over here. You can see LMQ. LMQ is an exterior angle for angle MPQ and MQP. So MPQ plus MQP when added will be equal to angle of deviation delta. So if we place the values over there, it becomes angle delta is equal to delta 1 plus delta 2. Angle of deviation is represented by delta. Delta is a Greek letter. Okay. Now we move further. As angle MPN is I1. You can see MPN is I1 because it will be vertically opposite angle. I1 angle of incidence, that side is angle of incidence, this side vertically opposite angles because the same rays have been traced back. So I1 is equal to delta 1 plus R1 from here. Yes. Can we say that? Because vertically opposite angles. So, delta 1 will be I1 minus R1. We can write that. And similarly, we can also write that I2 is equal to delta 2 plus R2. Or we can also say that delta 2 is equal to I2 minus R2. Now, the main delta will be I1 minus R1 plus I2 minus R2. So we have clubbed the I's together and R's together and we get it. Delta is equal to I1 plus R1 minus I1 plus I2 minus R1 plus R2 in brackets. Now, we move further. In triangle AP, in quadrilateral APNQ. So angle of prism is A over here. APNQ. This is the quadrilateral over here. It is formed from four sides. So we are talking about APNQ. Angle APN is equal to angle AQN. Both are forming 90 degrees over here. You can see those are normals. PN and QN are the normals over here. So they are making 90 degrees from the surface of the prism. Therefore, APN and AQN are equal. And that is 90 degree. Now, if these are 90 degrees in this quadrilateral, and we know that sum of interior angles of a quadrilateral is 360 degree. Now, if the sum is 360 degree and we already know that two angles are 90 degree, can we find out the sum of the other two angles? So that means it will be angle A plus angle N should be equal to 90 degree because P and Q are already 90 and 90. So 180. So 180 has been reduced from 360. So we are only left with 180. So angle A plus angle N should be equal to 180 degree. Now PAQ is angle of prism, so we will write it as A, and PNQ we are writing in terms of A, that is 180 minus A. We will use it, and therefore we have put the equation in number over there. Now in triangle PNQ, okay, we are talking about the triangle PNQ. R1 plus R2 plus N should be equal to 180 degree. So can we say that angle N is equal to 180 minus R1 plus R2? We can say that. Now, we already had an equation that PNQ is equal to 180 minus A, and right now we calculated N is equal to 180 minus R1 plus R2. Now we can put both, as both sides we have angle N only, so we can equate the equations. So we get from here that A is equal to R1 plus R2. Now putting all the values from the main equation 1 and main equation 2, we get delta is equal to I1 plus I2 minus A. As R1 plus R2 is A, so in place of R1 plus R2, we have written A. So delta is equal to I1 plus I2 minus A. Now A goes to the other side, which is having a negative sign, so it becomes A plus delta is equal to I1 plus I2, or I plus E, that is angle of emergence. I2 is angle of emergence over here. So I1 plus I2 is equal to A plus delta. So this was the complete proving over here. This was a little bit tedious. This is long but not difficult, and it is taking up very easy steps. So one or two times if you listen, you will get to know that how is it coming. Now we are about to do factors affecting angle of deviation. Now what are the factors which affect the angle of deviation? We have right now studied about angle of deviation. That is when angle of incidence, incident ray and emergent ray are traced back, they form angle of deviation. Now how is this deviate? How is this affected? We are going to study now. Now the first point is angle of incidence. Now if you can see the side graph, it shows angle of incidence on x-axis and angle of deviation on y-axis. Now you can see as the angle of incidence is increasing, the angle of deviation is decreasing. And there is a point where it comes, stops, and after that, as the angle of incidence increases, angle of deviation also increases. Okay, this happens in all the cases, and this point where the angle of deviation is minimum is known as angle of minimum deviation. Okay, and this affects the angle of deviation. Obviously, angle of incidence affects angle of deviation. How? We have understood. Firstly, what will happen? Angle of deviation will decrease on increase of angle of incidence. Then it will come to a minimum point, and then it will start increasing with increase in angle of incidence. Okay, so we move further. Now this figure shows the same, that angle of minimum deviation is equal to I over there. So both are same at that point. So deviation angle first decreases with increase in angle of incidence and then starts increasing. And angle of deviation value is calculated by 2 times of angle of incidence minus angle of prism. So 2I minus A will give you angle of deviation from here. Okay, so we move further. So the next point on which the angle of deviation depends is material of prism. That means the refractive index of the material. So the dependence of angle of deviation on refractive index is linear. That means directly proportional. As refractive index is directly proportional to angle of deviation. This means denser the medium, greater is the angle of deviation. Rarer the medium, lesser is the angle of deviation. So it is linear, it is directly proportional. Increase in angle of deviation will give that the medium is denser, and decrease in angle of deviation will say that the medium is rarer. Okay, so we move further. So the next point on which the angle of deviation depends is angle of prism, and this is also linear, that is directly proportional. As the angle of prism will increase, so the angle of deviation will increase, and vice versa. Okay, so we move further. So, another and the last factor on which angle of deviation depends is the color or the wavelength of light used. Now, it is inversely proportional to the wavelength of the light. So, angle of deviation is inversely proportional to the wavelength of that colored light. So if we compare red and violet colors over here, then what will happen? As the wavelength of red is greater than wavelength of violet color, therefore angle of deviation for red color will be less than the angle of deviation for violet color, as they are inversely proportional. Okay, so we move further. Now students, you must have seen that if you have kept a pencil in a half-filled glass, half-filled transparent glass, and if you would have seen from the sides, you would have seen that the pencil appears broader when it is dipped inside the water. Till the level of water is there, it seems to be broader and it seems to be bent. That means it seems to be that it is broken from the point where it is in water and air. At that surface, it seems to be broken from that point and it seems to be broader. Now, what is the reason behind this? We are going to study now. Now, if you see this diagram, you may consider anything. So O is the object over here in this diagram. O is the object which is at a depth of AO from a point A. Okay. And this is air and water. The medium is air and water. Okay. Now, if the object is viewed at 90 degree, there will be no deviation. If the light ray enters at 0 degree angle, there would be no deviation. So the object is seen from a angle. That means from the sides, from the slant side. Okay. Now that is why it is mentioned that when the pencil is kept in the water and seen from the sides, not from the top, not making an angle of 0 degree, but making an angle which is other than 0. Okay. So that means it is seen from the sides. Now, if you see that O is the object and it is seen from somewhere point C. Okay. Now, ray of incidence, the light ray travels from C to B. So, angle of incidence over here. Or if the light ray is going from O to the eyes, so OB, you can see, is the angle of incidence, and BC is the angle of refraction. As the light ray is coming from denser to rarer medium, it is moving away from the normal. Now, when the refracted ray is traced back, it comes to I. You can see over there. And that is the angle which is made over there. Now, we will study it in depth. Now, this was the explanation of the diagram over here. Now, we are going to study about the formula. Consider a ray of light incident normally along OA. So, I mentioned OA is normal over here. It passes straight from OAA dash. So it is going OAA dash without deviation because it is making 0-degree angle. Consider another ray from O, that is object, incident at an angle I. You can see the angle I over there along OB. OB is the incident ray. The ray gets refracted and passes along BC. So BC is the refracted ray. On producing this ray BC backward, it appears to come from the point I. So when it is traced back, it is assumed that it is coming from I. And hence, AI represents the apparent depth. That is why the pencil seems to be broken. That is why the coin appears to somewhere up from wherever it is actually. So apparent depth. So it appears to come from point I and hence AI represents the apparent depth over here. That means the false depth which is less than the real depth. So the false depth is less than the real depth. AO. So AO is the real depth over here and AI is the apparent depth over here. Okay. Since AO and BN dash are parallel, AO and BN dash are parallel rays, you can see in the diagram, and OB is the transversal. OB is the transversal, you can see over there. So, angle AOB is equal to OBN dash. Alternate angles we can say over there. You have done this parallel lines and transversal. So AOB is equal to OBN dash alternate angles. Now BIA dash is equal to CBN. Yes, corresponding angles. If CB is traced back, it is coming to I. So A dash IB or BIA dash is equal to CBN corresponding angles. Now that means R is equal to R and I is equal to I at point B. Okay. Now in triangle BAO. Now see the triangle BAO. BAO. Sin I, from 90 degree you see where is the perpendicular and where is the base and where is the hypotenuse. So in triangle BAO, sin I, that means perpendicular upon hypotenuse. Sin I, that is at O, perpendicular will be AB and hypotenuse will be OB. So sin I is equal to AB upon OB. Now in triangle IAB, what will be the sign? Sin R is equal to AB upon IB. Yes. Now, refractive index is sin I upon sin R. So, sin I upon sin R. So, AB upon OB divided by AB upon IB. AB and AB is cancelled. We get IB upon OB. Yes. If you don't understand over here, you can take a copy along with me and then you can do also. So refractive index comes to IB upon OB. Now, this was M mu A. Now, you all have studied the principle of reversibility. If I have to find out A mu M, I will do 1 upon M mu A. And therefore, it will become OB upon IB. Now, we know that refractive index of air with respect to medium, since the point B is very close to point A, we are assuming that the light ray which is normal and the light ray which is coming slanting is very close to each other, and therefore the object is viewed from point vertically the object. So it is assumed that it is seen almost from the 0-degree angle only. That means it is seen above from the object only. In that case, B will shift to A. As B is assumed to be very close to A, so in physics we say that B takes the place of A over here. So OB will become OA and IB will become IA in that case. Hence, A mu M is OA upon IA, which is real depth. OA is the real depth and IA is the apparent depth. So from here we get a formula that refractive index A mu M is equal to real depth upon apparent depth. Now, shift. What is a shift over here? Shift is real depth minus apparent depth. So, whatever is a real depth, when apparent depth is deduced from there, is subtracted from there, we get the shift. How much it has shifted? How much it has shifted? Shift OI is equal to real depth minus apparent depth. Now, shift can be given a formula also. Real depth, if you take common, real depth minus, if you take common real depth, 1 minus apparent depth upon real depth you will get, and apparent depth upon real depth will be 1 upon A mu M. So you also get a shift formula as real depth multiplied by 1 minus A, 1 upon A mu M. When you open the bracket, you will get the same thing as above. Okay, so this was all about this slide. So we move further. Now, the factors which affect the shift depends on refractive index of the medium, the thickness of the medium, that means how much it is denser or rarer, and third is the color or wavelength of the medium. So, if refractive index is more, the shift is more. If thickness is more, the shift is more. And if the color and wavelength is, it is reciprocal over there. So, if wavelength is more, shift is less, and so on. Okay, so we move further. Now, as you can see, here we have taken a few questions based on refractive index. Now, we'll take each question one by one. So, let us understand the first question. A 12 centimeter thick plate. So, the thickness, the real thickness has been given as 12 centimeter. A 12 centimeter thick plate is kept above a picture. If refractive index of glass is 1.5, then find out the depth at which we will see the picture while looking through the glass. That means we have to find out the apparent depth of the picture. Now, according to the formula, refractive index is equal to real depth upon apparent depth. So, real depth, in place of real depth, you will keep 1.5. In place of refractive index, you will keep 1.5. In place of real depth, you will place 12 centimeters, and apparent depth you have to find out. So you will assume it as x, y, z, anything. Now let us assume it as x. So x is equal to 12 divided by 1.5. So decimal will be gone. So it will be 120 upon 15. If you cancel, 3 5s are 15 and 3 40s are 120. And then if we divide, it will be 8 centimeters. So the picture will appear at 8 centimeters while looking from above the glass. Okay. Now we come to question number 2. There are two similar glasses of same depth. So the depth of the glasses is same. One is filled with water. Refractive index of water has been mentioned. And one is filled with liquid. The refractive index of liquid has been mentioned. Which glass will appear to have more depth? So the question is asking which condition will have more apparent depth. So let us place the values in the formulae. So refractive index 1.33 is equal to real depth upon apparent depth. and 1.40 is equal to real depth upon apparent depth. Now here the real depth is same, as they have mentioned that there are two similar classes of same depth. Real depth is same. So now apparent depth 1, that means in the first case, apparent depth 1 is equal to real depth upon 1.33, and apparent depth 2 is equal to real depth upon 1.40. So I think if you must be knowing this concept that if you divide with a smaller denominator the same number by a smaller denominator, you will get a greater value. So that means when the real depth is same, the real depth is divided by 1.33, you will get more apparent depth. So apparent depth in case of water is more. That means which glass will appear to have more depth? The glass which is filled with water will appear to have more depth. Okay. This was the solution for question number 2. Now the third one. A fisherman can see a fish at a depth of 3 meters. Okay. A fisherman can see that at his apparent depth. A fisherman can see a fish at a depth of 3 meters. If refractive index of water is 4/3, then how long jack he should put in water to catch the fish? Now, when he has to put a jack, he has to put it at the real depth, then only he can catch the fish. So in that case, real depth is to be calculated. So 4/3 is equal to real depth upon 3. So refractive index multiplied by 3 will give you the real depth. So 4/3 into 3, and that comes to 4 meters. So your answer is 4 meters over here. So these were few of the questions which have already been appearing in boards. And this was here to just give you a visualization that what kind of questions appear. So you have got an idea of how to go for the numericals, what is real depth, how is minimum deviation calculated, what are the factors affecting these things. So try to read and understand the concepts. These are very amazing concepts and you will love understanding it. So till then, I would just tell you to go through the book, whatever is given over there, read it, understand it. If you have any problems, please do ask me in the comments below. Otherwise, till then, we take a rest and we'll meet in the next class with a fresh part of the chapter. Thank you so much. Take care. Bye-bye.